And welcome back to Math Bosses. We all know that the standard method for multiplying matrices can be confusing and error prone, and that is why in this video we'll look at two different tricks, really easy tricks for multiplying matrices. We have our question here to find the product of these two matrices. So there are three things common to these two tricks that I would like to point out first. The first thing is that we'll consider our first matrix here as the multiplier matrix, that is the matrix with which we multiply. Then we'll consider our second matrix here as the multiplicand matrix, that is the matrix to be multiplied. The second thing is that we must maintain an order of flow. For the multiplier matrix, we have to take our values in the horizontal direction from left to right. And for the multiplicand matrix, we have to take our values in the vertical direction from top to bottom. So altogether, we move in the inverse L direction. The third thing to note is that we have to check if it's possible to actually multiply the matrices that we are asked to multiply. Our multiplier here is a 2 by 2 matrix, where the number before the sign represents the number of rows, while the number after the sign represents the number of columns. The multiplicand is a 2 by 3 matrix, and the same applies for the row and column naming. So when the column of the multiplier matrix and the row of the multiplicand matrix are equal, we say that the matrix is defined. That means it is possible to multiply the matrices together. Then the row of the multiplier and the column of the multiplicand matrix come together to give the dimension of the resulting matrix. So we take our first trick. As seen earlier, when we multiply these two matrices, we should get a 2 by 3 matrix. So our answer should look something like this, where these boxes represent numeric values. Now that we have the structure, let's draw two lines like this, then take away the square brackets. Now this is where the real thing begins. In our multiplier matrix, we pick the first row since we always have to go from left to right here. We take these values 3 and 5 and place them in line with the first row in our grid, separating them with a comma. Then we take the values on the second row, 2 and 1, and place them on the second row in our grid, also separating them with a comma. Then we move on to our multiplicand matrix and pick the first column since we have to go from top to bottom here. We place these values 2 and 0 beside each other in line with the first column in our grid. Then we take the values on the second column and place them here, also in line with the second column in our grid. Finally, we take the values on the third column and place them here in line with our grid, not forgetting the comma. Let's call all these values coordinates. Now we have something really similar to a multiplication grid. So let's see what follows. These two coordinates intersect here. So we take their first values and multiply them. Then we also take their second values and multiply them. We can add them together to place here. For the next one, these two coordinates intersect here. So we take their first values 3 and 4 and multiply them. Then we also multiply their second values 5 and 3. Then we add them to place here. For the next one, these two coordinates also intersect here. So we multiply their first values, multiply their second values, add them and place here. We follow this same process for the other 3 missing parts to arrive at this. Following the rule of BODMAS, we multiply where necessary, then we add them up to give that our final answer. Now let's move on to our second trick. It still stands that by multiplying these two matrices, we will arrive at a 2 by 3 matrix having this structure. So for this trick, our primary focus is on the arrangement of values, and this is how it goes. In our multiplier matrix, we take these values on the first row and arrange them on the first row of our resulting matrix this way. Then we take the values on the second row and arrange them along the second row of our resulting matrix this way. Now we place a multiplication sign beside all these values we have gotten from our multiplier matrix. In our multiplicand matrix, we take the values on the first column, since we have to move from top to bottom. We arrange them along the first column in our resulting matrix, placing the first value 2 here, then the second value 0 here like this. Then we take the values on the second column of the multiplicand matrix and arrange them along the second column in our resulting matrix, placing the first value 4 here, then the second value 3 here like this. Finally, we take the values on the third column of our multiplicand matrix and arrange them along the third column of our resulting matrix, placing the first value 1 here, then the second value 6 here like this. We place a plus sign in all these spaces, then perform the necessary operations by multiplying first, then adding up to give our final matrix as this.